The next topic in Python that we're going to cover is this package or library in Python called Numpy, which is short for numerical Python. Well, this particular webpage says it's Python for data science, namely helps manipulate data and do various operations with data. It kind of has a variety of functions for matrix and array manipulations that are similar to MATLAB, and in fact, I think modeled on MATLAB because I think NumPy came after MATLAB did. So you'll find that a lot of commands are similarly named and so on. In any case, so let's jump in. Here is a random website. There's a million websites doing tutorials on NumPy, which you can certainly look at as a complement to my own video here. But for instance, here's one which gives a list of various functions in NumPy, some of which we will go through. And I have my own notes scribbled down here that I will try to cover. We're going to use Google Colab. Here's another official NumPy webpage, which has references to various NumPy functions. Okay, so various kinds of functions, etc., etc. There's NumPy. There's also SciPy, which is scientific Python, I suppose. And this is also something that you can look at. Anyway, so there's a few different libraries that people that do data science use: NumPy, SciPy, Matplotlib, which people, if you want to create MATLAB-like plots, you can use that. These are for numerical computations. This is for specifically for scientific computing. For instance, if you wanted to solve ordinary differential equations and things like that, I believe there are functions here to do that. Pandas is for data management, and data structures. SymPy is like MATLAB's symbolic toolbox if you want to do symbolic manipulations. Okay, so let me just jump into my NumPy, which is fundamental to doing machine learning, certainly in Python. Okay, so I have my MATLAB window also open here. I might type in some MATLAB commands and sort of show corresponding NumPy commands, just to occasionally compare and contrast, perhaps. Okay, we are going to use Google Colab, so that's Google Colab. I just Google searched Google Colab, and let me create a new notebook, brand new notebook. Okay, so before we can use NumPy, we have to import NumPy because it's a specific library, and then we can import it as np. So instead of calling numpy dot blah blah blah, we can do np dot. This is what that means. np is just a short form for NumPy. Okay, so we've just run that. Let me create another cell. In this notebook, I'm going to try to write and run the cells in order. Intro NumPy ME5194 or something. Okay, so let's create an array. We can say np dot array. And then we can create an array, and we can create it like this: 1, 4, 3, or something. It's happy, and then we can say print a. One, 4, 3. These are, I think, by default integers. So we can, if we go 1.0, 4.0, 3.0, it will cast them as floating point numbers. in any case. So that's a NumPy array. It's a one-dimensional array. Um, let me do b equals a 2D array now. So 2D array has, well, two 1D arrays. So basically like that, where I'm going to do 3, comma 3.0, comma 1.0, comma 4.0. That's the first row. And then the second row, let's say, is 2.0, 1.0, 1.0, something. And they're just making up some numbers here. And then we can say print b run. That's the array. We can also do 3D arrays. Let me add that. C equals np dot array. This is going to be complicated. But what I'm going to do is, for a 3D array, I'm going to append two 2D arrays. So let's see if that works. B is already a 2D array. And then I'm going to do B, and then I'm going to say print C. So that's actually a 3D array, I think. So to actually see what sort of dimensionality of the arrays is, you can actually see, use the command a dot. So if you go any of these arrays and then go dot, Colab automatically tells you all kinds of functions that can operate on this array. Okay, these are all things that you can operate on array. And I think there's one called ndim. You can say print a dot ndim. So a is a one-dimensional array. So if you want to be more precise, well, let me just run them in sequence. You can say print okay, so B is a b dot ndim array. B is a two-dimensional array, I guess. Okay, B is a two-dimensional array. I slightly violated my principle and ran this cell twice, but that's okay. No harm done here. Similarly, we can say print, copy this, paste it here. You can say C is a C-dimensional array. C dot is a three-dimensional array, okay? Because it's got two-dimensional arrays stuck next to each other, okay? All this is rather similar to MATLAB, so we can go A equals, I don't know, 1, 2, 3 or something. B equals, in MATLAB, of course, we can go something like that, or C equals B, something like this. Well, in MATLAB, I guess it's a bit more complicated. We can go okay, so I just defined a three-dimensional matrix where this first slice is B, the second slice is also B. So if you go C, it's like a 3D array. If I go size of C, it's got 2, 3, 2 arrays, okay? We can also, just like we did size here, we can do that here. I think the command is shape in MATLAB. Print a dot shape. It's like 3 comma 1 basically. Or we can do print B shape. B is a 2 comma 3 matrix, 2 rows, 3 columns. And then print C shape. It's got, well, not sure how to call this, but along the first dimension, it's got sort of 2 rows, 2 columns, and then 3 slices, I guess, of that 2 by 2 matrix. Okay. And you can imagine something like this could be an image of some sort. Okay. Okay. This could be an RGB image, for instance, with 2 by 2 pixels and 3 channels. Okay, so that's sort of defining the arrays by just entering the elements. We can also define the elements just like in MATLAB. In MATLAB, we can go A equals zeros of 6 comma 5 or something, and you get a 6 by 5 0 matrix, ones matrix, and so on. So let's do that. For instance, let's say D equals zeros, 3 comma 4, print D. Okay, what did I do wrong there? Zeros is actually a function from Numpy. So instead of saying zeros, I should say numpy.zeros or np.zeros. Well, that's also wrong. Data type not understood. So what do we do next? What we do is look at this. For instance, so it says 3, and then once it says 3 comma 4. So you want to go back and look at how these things are defined if you're not familiar completely. Okay, now we got that right. Okay, excuse me. So let's do another one. Now that we figured that out. So you should always have some kind of way of Googling these commands. If you want ones, 3 comma 4. Let's try that. And then print D. Whole bunch of ones there. Now let's go back to B here. And let's say we want to access a particular element. So let me just print B here again, just so that we have this on the screen. And then let's say we want to, let me just do the same thing here, just to do a comparison with MATLAB. 314, 211. Okay, so if I wanted to do B1 comma 1, that's 3. Okay, that's a first row, first column. How should we do that in Python? Unfortunately, if we do print B1 comma 1, let's try that. We get 1, not 3. Okay, we get 1. Now, why is that? Because as we discussed before, Python does indexing starting from 0. So this is actually the 0th row, 0th column, and this would be the first row, first column, and so on. So what we are actually getting is this number for 1 comma 1, I believe. So if you wanted this number 3, we have to go print B 0 comma 0. Okay. So that's super important to remember. It's a dramatic difference with MATLAB. Some languages and programming paradigms start indexing arrays and so on from 0, and some languages do start indexing arrays and matrices from 1. I personally prefer indexing from 0, but it looks like people's preferences differ. Anyway, so Python does starts indexing from 0. A funny thing in Python, which I sort of don't like using, is it also allows negative indices. So we can say print, let's see, b. Notice, by the way, I didn't quite emphasize this. Instead of MATLAB using parentheses here, or basically round brackets, Python uses square brackets for array indexing. Okay, so let me do 0, comma, and then for the column, let's do -1, and it gives me 4. Okay, so the -1 corresponds to the last element. So in this case, it's the last column. Okay, and then you can do -2 if you want, and then it'll be the last but one element, and so on. So it's good to know. I would never use this in a program myself, probably, but it's good to know. It's kind of similar to MATLAB's 1, end. Okay, so 1, end is the last element here. Okay.